Okay, just open that data set. And let's check that do you have variables that I would like to use today. So we are going to use age, education, experience, and IQ, and also wage here. Some variables that you have right now might be a little bit different from mine, but the main variables that I told you should be the same. So we are going to use age, education, experience, IQ, and wage. So if you have different data set, please let me know so I will upload another one for you. Okay, and I would like you to follow the instruction that I am showing on screen. So first, again, I would like you to run regression, the following equation that I am showing you right now, and then I would like you to save the results. So this time I don't want you to just copy and paste on any programs, but I just want you to name the results that you have. And after you finish naming your results, you can generate a square of your residuals. I already gave you the command here. And for the fourth one, I would like you to plot graphs between wage and each independent variable. So by using this command, independent here, I mean like you have to put each independent. You cannot put all of them together, okay? For example, if you would like to plot a graph between age and wage, you have to put sketch pair age and wage. You have to use this command by using one individual at a time, followed by your dependent variable. And then I asked you a question. Are there any graphs that you suspect the heteroscedasticity issue? If you still remember, I mean, like while you are working on it, I will keep talking. If you still remember, like I think before your midterm exam, we already talked about it. I already told you like the heteroscedasticity graph or something like that, but I just drew it, right? But this time we are going to use a real data set, and I will show you which one you can see this graph you might suspect heteroscedasticity, something like that. But I remember, like I told you, you cannot just conclude about heteroscedasticity by plotting a graph. So we will have some statistic to check whether or not your model or your data set have this issue.
May I ask if we have to put our answer on some like other file?
No, you don't have to.
Okay.
Okay, it's going to be a good news. We will not have you don't have to submit any in-class assignment today. But just keep practicing, okay? I just want you to learn how to use eViews.
อาจารย์ครับ
ค่ะ
For the fourth question, do we have to select the regression line or have any special things?
For the first question, you mean like this one
The graph one.
or the graph one? Uh-huh.
Do we have to insert the regression line or?
Oh, it depends. You don't have to, but you can add it. Mm-hmm.
Okay, ครับ And within graph, we have to insert something in the box or not? Actually, I have forget how to do it.
Sure. Okay. So let me show you how to do it. I think what we can do together because I don't have to. I did not ask you to submit it anyway. So for the first thing, I asked you to run regression, right, between wage, age, education, experience, and IQ, right? Okay. So this is going to be your result. And then I asked you to name the result, right? So if you remember, just take a look at the menu tab of this window. Go to name, right? Actually, I asked you to name is like, oh, I'm sorry, it's in Thai. Like original regression, right? But you can name whatever you want. Just remember that you name this way. And then for the third one, I asked you to generate. You had square, so it's the square of residuals, right? This one, I think you also professional at it. So just type series and then name the variables that you would like. And then just take receipt square. Actually, like the size for the square is going to be the same as we used in Excel. Right? So after you type it, just press enter. So you already generate, you have square. And then I asked you to plot scatter graph. So actually there are two ways to plot a graph, right? So the first one, you can just type the command that I already gave you, the scat pair, and then just type the independent variable that you would like to plot a graph with weight. Right? For example, like if I would like to plot a graph between age and weight. So I'm going to type scat pair and then just type the independent variable that I would like to plot a graph with weight. So in this case, it's going to be age, right? And then press enter. So this is going to be the first graph that you got. And again, if you would like to save the result without copying and pasting, you can just name it again, right? So in this case, I'm going to name it as age and weight. And there is another way to making a graph. For example, if I would like to create a graph between education and weight, I can just click on the variables that I would like to create a graph. So in this case, I just click on education and weight. And then just open it as group. And then on the menu tab, just go to view and go to graph. So just click on it. And I want you to plot scatter graph, right? Just click on scatter. And from the question that your friend asked me, if you would like to have a fitted line, like a linear fitted line, you can just use regression line here. So if you don't want to do anything, you can just go with the default one, right? And then click OK. You will get the second graph. So this way would be easier for all of you because you can just click on any other options that you want. For example, like if you would like to have the fitted line, you can just go and click it, right? But if you use a command, it's going to be a little bit complicated because you have to search, you have to Google like how to type a command if you would like to get some fitted line on your graph or something like that. So this one, the one that I gave you, would be the easiest one to plot like a very simple graph between your independent variable and your dependent variable. Right? But if you want something more complicated, I recommend you to just click on it. So open it as a group first and then just go to view and then go to graph and kind of like click whatever types of graph that you want, and you can give it some more detail on your graph. Yep. So now you are on the question number 4. So after you finish plotting graphs, just answer my question. I saw your answer. No. Yeah, that's why I told you like when you look at graphs only and try to figure out is there any variables in your model have heteroscedasticity issue. It's going to be very difficult because like most graphs look very the same. Okay, so I think most of you are done. So let me show you another 2 graphs, right? So for this one is going to be education and wage, right? And the last one, no, not the last one. It's going to be, oops. The third one will be expert, right? And wage. And the last one is IQ and wage. Yeah. Okay. So Ngọc told me that the last one, like the graph between IQ and wage, looks like it has a heteroscedasticity issue. Why you think is the IQ between IQ and wage, Ngọc? Do you have any idea why do you think it's this one? It just look Marco. Yeah, actually that's the correct answer. How about others? Do you think like is there any other graphs that you think it might have heteroscedasticity issue? Ah, maybe education. Yeah. So I think so. Yeah, I think like education and IQ might have heteroscedasticity issue, right? As I told you before, like last time, if you still remember, because it's before like midterm. So when you would like to check about heteroscedasticity, so after you plot a graph between the independent variable and your dependent variable. Oops. You can see something like a cone shape. So this one is y, this one is your x, right? And then you have your data here. So normally if your data has constant variance, they should look like, for example, look like this. They will go on like a straight line, right? Because they have the same variation in the. But if your data have an unconstant variation or variance here, it will look like a cone shape, like your friend told. For example, like the education, so this one is wage, right? Oh, I apologize for my handwriting. And this one is the education, right? So you will see that if you have, if your observations have low education, they have a very low variation in wage. But once your education increases, you can see that there is a higher chance of wage to be increased. I mean, like there is a higher variation in your wage as well. So they will not have a constant variance anymore. So it means that your data have a heteroscedasticity issue. So if I draw something like in your lecture, you will see that, okay, you have one variance for one education level, right? So for the observations who have lower education level, they will have like a very narrow variances. But once your observations have higher education level, you can see that, okay, the lower wage that they get and the higher wage, like the highest wage that they get, will spread out. They have like a wider data once you plot a graph. So it will look like a cone shape, like Ngọc told me. So if you just take a look at your graphs, you might suspect that education and IQ could probably have heteroscedasticity issue because they look like a very cone shape, right? So here is the IQ, and this one is the education. Yep. So if you take a look at the IQ, you can see that, okay, yeah, it looks like a very cone shape. So the higher IQ you have, the higher wish you will get, right? The same as the education. But as I told you, it's pretty difficult to tell that your data have heteroscedasticity issue by using graphs. So we will have some statistic to test it. So I want you to follow the rest of my instruction. So you already have the U hat square, right? I would like you to run another regression. So you have to regress U hat square on age, education, experience, and IQ. So basically just regress U hat square on your independent variables. So this one should be easy for you. Can you tell me that your F-test is significant or not? If you cannot remember, like you can see the probability of your F-test at the corner of your left. That will be the probability, the F-test statistic, and then the probability below the F-test. Yeah, it's significant. And can you tell me like how to interpret it if your F-test is significant? Can you remember from the lecture? So I just request you had square, right? On age, education, experience, IQ. Yeah. And then this is the second result that you got. And I told you that you can just take a look at the F statistic and the probability at the corner, right, of your left. So here, this is the F stat. So basically, like if you do it manually, you have to use the F stat here and then just take a look at the table. They have the F stat table. And to compare between the p-value that you get from the table and the p-value that you already set in your mind. For example, that's kind of like do it manually. But anyway, EViews already did it for you. They say like the probability of the F statistic here is about like 1001. It means that it's pretty highly significant, right? We already learned about it. And I already asked you like how to interpret if the F statistic here is significant. So if you look at your lecture, so the F test here, if you would like to test for heteroscedasticity, your null hypothesis is going to be homoscedasticity, right? And then your alternative hypothesis would be heteroscedasticity. and your F stat is significant, it means that we can reject or cannot reject. Yes, you're right. No, it means that we can reject null hypothesis. Right? So if we can reject null hypothesis, it means that it implies that you can accept your alternative hypothesis, which means that your dataset have heteroscedasticity issue. Make sense? Do you have any question? Yeah, I think most of you understood, right, about F-test. Okay, so this is the first way to test about heteroscedasticity. Why this one is so difficult to, to pronounce it? Heteroscedasticity. Yep, this is the first way, right? And the second way is that we are going to use some fancy statistic in e-views. So actually, like all of these statistics you already learned in your lecture, but we don't have to generate U hat square or something like that. So I'm going to just run my original specification, the first one that I already showed you, this one. So I'm going to request wage on any other independent variables that I am interested in. So just follow my step, okay? So we are going to request wage on age, on education, on experience, and on IQ. Right? And actually, this is the first result that you got. And we have the easy way to test for heteroscedasticity. Just go to View tab at the top of this window. Or actually, like if someone already saved your first result, you can just double click on it. You don't have to run another regression as I did. So after you open the window, like the result window, or you already finished regressing, just go to View tab, and then you will have residual diagnostics here. And you can see the heteroscedasticity test. So just click on it. So the first test that we are going to use is the BPG. So you learned two approaches, right? The first one is the BPG and another one is the white one. But I'm going to use the first one, the BPG first, and then I will show you another one. So after you click on the BPG, right, just click OK. And then you will get another result here on the same window. It will say that if it is showing you that the test that you are using is BPG, and it also shows you that the null hypothesis is homoscedasticity, right? So actually, like, is the same hypothesis that you are using in your F test, And the things that we are going to take a look at is the probability, or the probability on the right hand side. So all of them are significant. So the F statistic here and the observation multiplied with the R square is the same as what you have learned in your lecture, right? It's pretty much like a chi-square. So basically, like the statistics that we are going to use, I think there are 3 statistics, like the chi-square, F-test, and T-test. Right? So chi-square is another statistic, and actually, like, it's the same thing, like the same steps. So if you calculate it manually, you have to use the chi-square, the value of the chi-square that you got, and compare it to the chi-square table, and then use that p-value that you already calculated from the table and compare it with the p-value that you set in your mind. But anyway, it was already did it for you. Right? So you will see that all of them are significant. It means that your data have heteroscedasticity issue. And I would like you to freeze it. Just go to the menu tab and freeze your result here. So I would like you to compare between the BPG approach to the white approach. So for the original window, just click on View. And then go to Residual Diagnostic. And we are going to do the same steps. Just go to heteroscedasticity test. And this time we are going to choose white approach. So for white approach, you already learned in lecture, right? That can be just the independent variable, but you can also include some cross terms. So cross terms here can be like some interaction terms between your independent variables, and they also have some like square of your independent variables too. So just dig out on your include white cross terms. So we are going to compare all of the results that we can get, and then click OK. And again, just freeze it. And then go back to View, doing the same step. So just pick white approach, but this time we are going to include white cross terms. And then click OK. So you will have 3 results of the heteroscedasticity test. You will see that any approaches, like all approaches, will give you the same result. It means that your data have heteroscedasticity test. But for the latest one that you include some white cross term, you will see that, as I mentioned, they are going to square your independent variables, and they also have some interaction term between your independent variables. So this is just the different things. So you can include it or not include it. It's not going to be different. Okay. So now you know that how to check whether or not your data have heteroscedasticity issue. But once you find out that your data have this issue, how to fix it. So we are going to use robust standard errors, right? And how to do it? Just do the same steps we always do. Just request all of the variables that you would like to study. So in this case, I'm going to request based on age, education, experience, and IQ again. So once you have this window, the estimation window popped up. So normally we just click OK, right? And then we got the result. But this time I'm going to use option. So in options, we have a covariance method here. So when you click on it, then we have any other options for you. So we are going to use Huber White just to collect our standard error. So once you finished it, just click OK. The difference is that if you already saved your first result, just click on it and compare them together. Everything, almost everything is the same, right? You have the same dependent variable, you have the same method, the same observation, but for the second window, they also told you that you have a heteroscedasticity consistent standard error. It means that you are trying to fix the heteroscedasticity issue here. And you can see that both results are a little bit different. Take a look at the standard error. Right? They're different because the robust standard error is trying to fix the standard error in your result. And once your standard errors are different, your t-statistics are also different, because I already told you that to calculate t-statistic, we are going to divide our coefficient with the standard error to get the t-statistic, right? So once you are trying to fix your standard error, your t-statistics are going to change, and that is going to affect your probability as well. But since our first result, all of our variables are significant, so that's why once you are trying to fix the heteroscedasticity, it doesn't affect the probability that much. And again, do you have any question?
Professor, so like for this one, it means that they will adjust the heteroscedasticity for us, right?
Yes, we are trying to solve it, yes. But how can we make sure that we already solved this issue? The answer is that we have to go back and test it again. So after you already fixed it, right? We already did robust standard error. You have to go back and test it again. Just go to View, and then go to Residual Diagnostic, go to Heteroscedasticity, and test it again. Just follow our previous steps. Can anyone tell me that, do you still have heteroscedasticity issue or not? Do we still have heteroscedasticity? So our F statistic is significant. The probability of the chi-square of this one is also significant. It means that we can reject our null hypothesis, right? And null hypothesis is homoscedasticity. So if we reject our null hypothesis, it means that our data still have heteroscedasticity. Why does it happen? We already fixed it. Why do we still have heteroscedasticity? So just look at your lecture slide. There are two factors, right, that can affect your data set and cause heteroscedasticity. So if you remember, so the first thing is that if your model specification is correctly specified, you have pure heteroscedasticity. So once you fixed it, it's gone. But if your model specification is not correctly specified, even though you are trying to fix it, you still have this issue, right? So in this case, I used which? Age, education, experience, and IQ. All of them are in level. So how to fix it? Let's try to use natural log to transform your variable. So I would like you to regress. I'm sorry, it's supposed to be this one. I want you to regress, for example, managed. So trying to do regression for this equation. This is the first one. And trying to do this one too. So for the first equation, you just take natural log on your independent variables. And for the second equation, you just take natural log on your dependent variable. So after you finish the first regression, just trying to check the heteroscedasticity issue. And let me know for this one that you still have the heteroscedasticity issue or not. And then just move to do another regression for the second one. And again, test for heteroscedasticity issue. And let me know that you still have this issue or not. So if you cannot remember how to take natural log, just type this command, okay? Are you done? Do you still have a heteroskedasticity issue for the first one? For the first equation, after you transform, yeah, you still have a heteroskedasticity, right? And how about the second one? For the second one, you still have the issue? Okay, for the second one, you say you don't have it. Okay, so let me check. Okay, so for the first equation, I asked you to use just weights, right? And request is on log age, log education, log experience, and log IQ. Okay, so this one is pretty obvious. We still have, even though we already transformed our independent variables, we still have heteroskedasticity issue, right? And then, so if I'm trying to fix it, for example, like if I would like to use this equation, and then let's say that if I would like to do robust standard error, is it going to be fixed? No, we still have, even though we do robust standard error, we still have heteroskedasticity issue, right? How about the second one? If I used log weight on age, education, experience, and IQ. Okay, so this is going to be your result. And then we just checked on heteroskedasticity. Okay, so this one, just compare the results together. So after you transform your dependent variable into natural log form, you can say that you don't have heteroskedasticity anymore. Even though we have not done anything with the robust standard errors, right? So the things that the things that I did, it's just trying to regress natural log weight on any other independent variables here. And we don't have the heteroskedasticity issue anymore. How about if we are trying to just use the same regression here and trying to fix, I don't know, because we don't have it, but let's check if we do robust standard error. All of these variables are still significant, which is pretty good. So you can see that if you have a correct specification, you will not have heteroskedasticity. Right? If you compare to the first part that we already did, even though you are trying to fix heteroskedasticity, but if you have wrong specification, you still have it. You still have this issue. So I recommend you to just trying to transform your variables into different form. Like in this case, we just try transform it into natural log form, right? But we don't know which one is correct. Maybe like you can transform your independent variable, or you should transform your dependent variable. So the thing is that you have to do experiment by yourself, just trying to transform your data set that you have, your variables that you have, and just pick the one that you think you already solved the heteroscedasticity issue. Do you have any question? And again, to answer your friend's question at the beginning, like he already asked me, like if he was trying to fix it, he was trying to solve the issue, but they still have the issue in there. Is it going to be a bad model? As I told you before, like your estimator is still unbiased, right? But it's not going to be an efficient estimator anymore because you have, like your data doesn't have the constant variance in your data. And what's going to happen? So it's going to affect your t statistic and affect your probability here, and that's all.
Professor.
Mm-hmm.
So during like the grading of the projects, do you look at the process of how we do things, or like the model that we try to make the smallest variance and unbiased? I mean, like grading with correctness or process of how we get to the answer.
Oh, I got your question. Yeah, we will take a look at your process. I mean, like the way you are trying to fix the problem in your model. For example, like once you have a regression, right? So I recommend you to just show everything, like every steps that you did. Like at the beginning, you might show that, okay, this is the first regression that you have. And then you suspect that your model might have multicollinearity, like high multicollinearity, and how you test it and how you fix it. And then because of that, like after step, you might test about the heteroscedasticity, something like that. I mean, like I recommend you to show every step, like every process that you did. Mm-hmm. And just conclude that, okay, this is the best model. You already fixed everything.
All right, thank you.
Welcome.
อาจารย์ครับ
Huh?
If we try to find the heteroscedasticity for the first time,
Mm-hmm.
and is okay, we cannot reject the null hypothesis, so we don't need to insert the Hooper or something, right?
Yes, you're right. Yeah, you don't have to do anything with the robust standard errors.
โอเคครับ
Is there anyone still have question about project? Okay, so Dr. Sivapong already responded. I'm going to announce to you about the presentation schedule. It's going to be the first day is going to be November 24th. So we are kind of like arranged your schedule a little bit because we would like you to have a last week of, I mean, like normally we have the last week of this class at the first week of December. So we cancel all of that classes just because we would like you to be free in that week so you can prepare for your finals. So that's why we move our schedule to be 24th November, 25th November, and 26th November. And we will not have a lecture class. Yes. And the lab class also cancelled on December the 2nd. Okay, it means that the last day that you will study this class will be on November 26th. Okay, and for 24th, we will move your class to 4 to 6 p.m. and 25th will be the same. It's going to be 3:30 to 5:30 p.m. And for 26th, we are going to have all day class. Oops. So you are going to have your last lecture next week and your lab session next week, last lab session also next week. And you have a due date of your presentation slide submission next week too. And the week after next week is going to be your presentation for 3 days in a row. And then you're done.
Professor, how will you decide the order of the presentation group?
Yeah, I'm going to use the Excel to randomly assign the number for your group. So basically we have 3 days. Let me calculate it. So we have 600 minutes, right, for your presentation. And you have 30 groups here. It means that each group will have 20 minutes. So I will let you present just only 15 minutes because the instructor will give you some suggestion. I will let them give you some suggestion for 5 minutes. So presentation 15 minutes. Q and A for 5 minutes. Right? And
อาจารย์คะพวกหนูปีสี่มีติดเรียนวันศุกร์ที่26ตอน11 โมงถึงเที่ยงครึ่งอะค่ะ
11 โมงถึงเที่ยงครึ่งใช่ไหมคะ26นี้เนาะ
ค่ะอาจารย์
เดี๋ยวขออาจารย์แชร์สกรีนแล้วฝากพวกหนูบอกอาจารย์นิดนึงแล้วกันค่ะว่าพวกหนูอยู่กลุ่มอะไรอาจารย์จะได้ให้พวกหนูพรีเซนต์ก่อนวันที่24กับ25ไม่ได้มีติดอะไรใช่ไหมคะตามตาราง
สักครู่นะคะ
Okay, let's wait for your friends. It seems like they have like something to do on 26th.
ไม่ติดค่ะอาจารย์
โอเคค่ะ
ถ้าเป็นกลุ่มหนูนะคะหนูทำ2 คนแต่ของเพื่อนปีสี่เหมือนกันหนูไม่แน่ใจอะค่ะ
โอเค
แต่ว่าน่าจะไม่ค่ะ
Okay, so let me share my screen and then we will decide how to randomly assign which group should be present on which day. So I'm going to follow the number that you already put in your Excel spreadsheet, okay? And there are 30 groups here. So นิสิตเมื่อกี้เนี้ยค่ะ กลุ่มของคุณกลุ่มไหนบ้างอะคะ
กลุ่มที่สองค่ะ
กลุ่มที่สองใช่ไหมโอเค
ครับอาจารย์ครับ
ค่ะ
พ
ค่ะ
อดีว่าวันที่26ผมต้องไปโรงพยาบาลกับที่บ้านนะครับ
โอเค
ก็คือ24 25ได้ครับ2วัน
กลุ่มของกลุ่มคุณกลุ่มไหนคะ
เลื่อนลงมาข้างล่างนะครับ อยู่ข้างล่างล่างกลุ่มที่28ครับ
โอเค
ครับผมขอบคุณครับ
Is there anyone else to have a conflicted schedule? You have something to do?
อาจารย์คะ
อือฮึค่ะ
หนูกลุ่ม6ค่ะ ติดเหมือนเพื่อนกลุ่ม2เลยค่ะ
Okay. Is there anyone else? I saw that group 23 and 24. You are also fourth year students, right? Do you have a conflicted schedule as your friends? Okay. So if you don't let me know right now, I think you have to kind of like exchange the schedule with your friends by yourself, okay? Okay, so how about I assign group number 2, number 6, and number 28 on the first day. Do you have any problem with that?
no ค่ะอาจารย์
Okay, ค่ะ So, okay, how to deal with it? You have 30 group. Okay. Okay. And let me copy this one. And your friend have some conflicted schedule is number 2, 6, and 28. 2, number 6 and number 28 will be here.
อาจารย์ค่ะ
ค่ะ
หนูเห็นในคอมเมนต์มีคอมเมนต์กลุ่มที่20ด้วยอะค่ะ
Okay. And then I will assign group 20 on the first day as well. So we'll delete. What am I doing here? Okay, it's number 6. Give me some time, okay? Oh. Number 2, number 6, number 20, and number 28. Okay, and then the rest just assign randomly by Excel. Okay, so this is going to be the order. And for this to be 24th, November 24th, the first group. So we have 2 hours for 24th, right? So we should have 6 group here. Yep. Okay. So this is going to be the first set. So group number 2, 6, 20, 28, 29, and 21 will present on November 24th. And another 6 group will be on 25th November. Okay. And so another 9 groups will present on November 26th from in the morning. Nope.
อาจารย์คะกลุ่มที่13วันที่16ติดอีกวิชาหนึ่งอะค่ะ
กลุ่มที่เท่าไหร่นะคะ
23ค่ะ
อืม
sorry ค่ะ
Okay, so then I will move. So you have to switch with number 10. Okay. This is okay. So you want, oh no, I'm sorry, not number 10. So it will be on, oh my God, it's so confusing. So it will be on 23 ทราบกับ20 Okay. Sounds good.
โอเคค่ะ
Mm-hmm. Okay, so for the first 6 group, you will present on November 24th, group number 2, 6, 20, 28, 23, and 21. So the order of the presenter will be the same like this. So group number 2 will go first and followed by group number 6, okay? So it will be like this. And then another 6 group will be on November 25th. Okay. This one will be afternoon. Yep. Okay. Sounds good. So the first day will be for the one who have conflicted schedule. So you will be present first. Does anyone still have a problem with the schedule? Please let me know, okay? So I can change the schedule. So if you cannot decide today, maybe you have to exchange with your friends by yourself and just let me know, okay? And I'm going to post it on the spreadsheet that you already filled out. This one. So I'm going to have another column here. Presentation date. Oh my God. And I will put it in here. And then if you decide later that you would like to change your schedule, you just ask your friend, okay? You don't have to let me know. Just ask your friend. And then I will check the schedule before your presentation. And I will call you.
อาจารย์ครับ
Mm-hmm.
do every group have to join to the meet ครับ or just only the group who have to present in that day ครับ
I recommend everyone to join it. Yeah, except just for some people who have conflicted schedule. You're already informed. Yep.
โอเคครับ
Mm-hmm. Okay. Does anyone still have question about your presentation schedule? So I apologize for rearranged your schedule and everything, but we would like you to be free on the last week of this semester so you have some more time to prepare for your finals. But if you have a conflicted schedule, just let me know, okay? Okay, so we still have about 35 minutes left. If you have any question about your project, you can ask me, okay? And for those who don't have any question, our class are already done for today.
Professor, so like, can I have question with the research, I mean project?
Sure.
So if our dummy variable, right,
Mm-hmm.
if the data of it, like many of the observation contain like just a lot of one and like only one is zero, will it cause a problem?
I'm sorry again, please.
So if our data of our dummy variable and all of it contains like one and only one number that like one observation that is zero, is it gonna cause a problem?
So you mean like you have different variables, but for one observation? For example, like if you collect data for a person number one, every variable is equal to zero. Is that right?
Wait, hold on. There's an airplane. So we have the price where we just categorize it into like expensive or cheap, and the expensive one will we make it number one for the dummy, and then the non-expensive one is zero. So in the data, it's like all of them are one because like they belong in the same category, and only one of them has zero in it.
Oh, yeah. Yeah, it will cause a problem because you don't have any variation in your variable.
But it's dummy.
Yes, it's almost like a dummy, but actually you only have one value in it. So it's not like a, how to say it, you are trying to generate dummy, but actually it's like a constant. It's not a dummy, it's just a constant because in every observation you have just only one value in there. There is no variation. Even though you have one observation that has zero, but it's almost like no variation in it.
So, but then like this variable is for us, we think that is important for our table, but like the data is really there's no difference between how do I say, between them because the prices in Thailand are the same.
So
Yeah.
how did you categorize it? Like which, for example, like if which values did you define it as like expensive price or cheap price?
It's in their website, and we should see that the price in metropolitan area, they have the lower price in the residence water, and for the provincial is more expensive. So we categorize is as more expensive.
Okay, so how about can you find average price from your data?
It's difficult because like they have the ranges, and it depends on how much water they use also.
Okay.
And there's no data like that.
I see.
What is it possible if we have like 3 observations that all have 1 and all have 0, and all the other observations have 1? Would that be okay?
I mean, like you can just put it in there. It doesn't matter. But I doubt that is going to be insignificant. As I said before, like it's going to be like almost no variation in there. I mean, like you can put it in there. It doesn't have any problem with it. But I doubt that it will be insignificant.
Okay.
Yeah.
Okay.
I mean, like actually, like I am thinking about if you can find average. For example, if you can find average, you can kind of like define it like below average or average and above, something like that. But if your data is in range,
Yeah, it's not possible to find average because we don't know how much water people use. So we because it's like a tariff system.
yeah, maybe you can try first. Just put it in there. But yeah, I think it will not be significant. But if you think it's kind of like important to add this variable, you just add it in there.
When we test, because we have already tested with the current model, it is significant.
Oh, really?
Like, yeah. It's actually like probability is 0.000. Like the most significant in our model.
Oh, okay.
Yeah.
I'm surprised.
Yeah.
Oh yeah, so it means that there's no problem at all.
Okay.
Okay.
Yep. All right.
Okay.
Okay. Thank you.
Okay, Channel.
ถามเป็นภาษาไทยได้แล้วใช่ไหมครับ
ค่ะ
เหมือนกับสมมติว่าผมทำมันก็จะมีสมการที่เป็นไอเดียลของเราก่อนถูกต้องไหมครับว่าแบบเราต้องการให้นี้มีอะไรบ้างอย่างเช่นของผมทำเป็น FDI ผมต้องการให้มี GDP wage rate tariff rate แล้วก็ HDI อย่างเงี้ยครับแต่ว่าพอทำขึ้นมาจริงๆแล้วเนี่ยตัว tariff กับ intercept อะครับมัน not significant เราต้องมาสรุปให้เป็นสมการที่เราได้จริงๆหรือเปล่าครับว่าแบบเราต้องตัดสมมติว่าของผมได้ tariff กับ intercept ของผมเนี่ย not significant ผมก็ตัดทิ้งออกไปจากโมเดลได้เลยหรือเปล่าครับเวลาตอนที่มาสรุปสมการที่เราคำนวณได้มาแล้ว
ใช่ค่ะก็คือมันไม่ได้มีผลกับตัวแปรที่คุณสนใจถูกต้อง
โอเคครับแล้วก็ reference ของผมสามารถเหมือนกับของผมฟังมาจากคลิปวิดีโอนึงที่เขาพูดขึ้นมาเกี่ยวกับ tariff rate และส่งผลต่อ FDI อะไรประมาณนี้ครับแล้วถ้าเกิดผมเอาอ้างอิงจากที่แบบเป็นบทความของเขามาพูดได้ไหมครับว่าเหมือนกับเขาบอกว่าการที่เราตั้งกำแพงภาษีเพื่อผลักดันนักลงทุนต่างชาติให้เข้ามาลงทุนอย่างนี้ครับแล้วเราก็อยากจะเช็คว่าบทความนี้เนี่ยเป็นจริงไหมถ้าเราเอามาคำนวณ
ได้ค่ะขอให้มีอ้างอิงแล้วกันถูกต้อง
โอเคครับแล้วก็อีกคำถามหนึ่งครับเหมือนกับของผมครับถ้าเกิดเราหา FDI ถ้าเกิดแยกเป็น manufacturing